Hello, Math 6. How you guys doing? Today I've got an introduction. We're talking about the coordinate plane. And as you can tell, I've got my handy-dandy little whiteboard here. If you do have graph paper, that will be best. You don't need it, although it's highly recommended. And this is actually our last lesson for the year, which I know, crazy, right? We do have, quizzes and a couple other things to talk about, but this is going to be kind of the basic thing. So, this is the coordinate plane again. It's known as the Cartesian plane, Cartesian coordinates, Cartesian whatever else. It's based on this guy named Descartes. Anyway, I'm actually going to show you what you can do if you don't have lined paper, or if you don't have graphed paper. You can draw it out. So I'll show you guys what it'll look like if you just hand draw it. Right, I'm going to draw as straight as I can a nice vertical line, and then a horizontal line which goes about through the middle of it. Okay, that's not too bad. At the top and bottom and sides of each of these lines, I'm going to say they go on forever and ever and ever. Now, these are known as axes, right? Or axes because it's plural. This vertical line makes an axis known as the y-axis. So I'm going to label it up there. Whereas this horizontal one is the x-axis. Now, all of our points that we use, we call them ordered pairs. Ordered pairs. And ordered pairs always look like an x value, comma, a y value. Now, remember, these are variables, but what they're talking about is this. This is how they relate. Now, where these two axes intersect is this point right here. Actually, what I'm going to do is I'm going to erase that, color it in a different color. Ooh, Mr. Bulger getting fancy. And this is point 0, comma, wow, you can't really read that. That's too small. It's point 0, comma, 0. And this is known as the origin. Rather, I'll write that down here so that way I have more space. I'll just write it as an example. Example 0, comma 0. That is the origin. Now, what I'm going to do is each line, I'm going to do little hash marks here. This is why graphing paper is usually a little bit nicer. 3, 4. I'm just going to make mine 5 wide in each direction. 2, 3, 4, 5. Now what you'll want to do is you want to make sure they measure the same amount. You don't want to call that 1 and call 2 way up here. Don't be crazy. That one I only made 4, and this one I'll probably only make 4, 3, yeah, 4. That's okay. Don't worry about that too much. Now each of these measures 1, 2, 3, 4, 5. And again, I'm starting at 0 and counting 1, 2, 3, 4, 5. But if we had a regular number line and we were going left of 0, we're going to call it -1, -2, -3, -4, and -5. And it's going to be very similar going vertically. 1, 2, 3, 4. And from 0, it's -1, -2, -3, and -4. Now, there's obviously a bunch of different ways you could do that. You can color code your numbers differently than your hash marks, differently than your lines. There's a bunch of different ways we could do that. I'm just going to keep it simple so as not to be confusing. Now, there is something that we need to talk about, and those are this fancy word, quadrant. That's a U. B-R-A-N-T, quadrant. Now, a quadrant is a section or sections of the, I don't know why it follows my hand. I'm really sorry for the shaking. The coordinate. The coordinate plane. That should be an E. Sections of the coordinate plane. And this is how they break up. Now, if you could guess, quad always means 4. And there are 4 sections. Okay, so going up to my graph again. We start in this whole region, this whole section. All of my x values are positive, and all of my y values are also positive, right? That's the fanciness of how these coordinate grids work out. All numbers in here are going to be positive x values and positive y values. This is known as quadrant. I'm just going to label it Q, quadrant 1. Now, that might look like quadrant I, but we're using Roman numerals. So think of it like quadrant 1, but we're using Roman numerals. Now, the second quadrant is over here where all of our x values are negative. So our x values are negative, but our y values are still positive. And this is quadrant 2. Okay. Now you might be confused why I'm doing positive, comma, positive. Well, I'm talking about my ordered pairs here. So my x values are positive and my y values are also positive. Whereas here in quadrant 2, my x values are negative, right? This is the x-axis, this is the negative side, but my y values are still positive. Okay. Now, our quadrants go kind of in a C shape as we number them. So down here, this will be quadrant 3. And in quadrant 3, all of our x values and all of our y values are negative. So quadrant 3 looks like negative Nancy. And finally, we have quadrant 4. Quadrant 1, B, because it's 1 before 5, which is 4. And here my x values are positive, but my y values are negative. Positive, comma, negative. Okie dokie. So this is an introduction to the coordinate grid. Now, let's see. let's say I've got, okay, I do have a couple more things to talk about. So what I'm going to do is I'm actually going to erase the quadrant business, so that way I still have my nice little grid. And yep. Okay. What if I have a point? Oh no, I just dropped the cap on the floor. It's gone forever. Let's say, okay, let's say I have a point here. How do I label that point? Well, first I need to find the x value and then the y value. So I'm going to call this point A. And let's say point A, so its x value, it looks like it lines up with 2. So its x value is 2. 2. That's a really good looking 2. And its y value happens to also be 2. So the point is at 2, not as nice of a 2. But A is at 2, 2. Now let's go up here. And let's call this point B. Yes, I am going in alphabetical order according to the quadrants. I'm trying to breed some consistency. Okay. Point B, again, we're going to do x, y. My x value looks like the point is at -1, and its y value is at +3. Now, notice what I'm doing is I'm lining up where it comes on the grid, and then the y value, I'm coming over this way. So I'm measuring my points. Now, if I didn't have any of this, if I didn't have even the grid, this would just be a point somewhere off in space, out in the middle of nowhere. But this guy, this Cartesian fella, he realized this will be a great way to measure graphs and to follow things that, you know, this is information. You see these kind of graphs everywhere. Okay. Moving on, let's say we've got a point about here. Yeah, we'll call this point C. Well, point C is at about -4. And let's see, point C is also, it's a little crooked, but it's about -2. Is that where it is? About negative. Well, it looks like it's kind of halfway in between both -1 and -2. So let me actually do a good job of that. There we go, -2. Still not as good as this 2 here. Wow, that's beautiful. Okay. And finally, we're at point D. That's at about 5, -4. 5, -4. Now, if you remember our quadrants, in quadrant 1, both x and y are positive numbers. In quadrant 2, x is negative, y is positive. Quadrant 3, both of my numbers are negative. And in quadrant 4, my x is positive and my y is negative. And that's the case. Now, with these numbers, all we don't do anything. We don't subtract, we don't multiply, we don't change these. These are just here for reference. These are just here as labels to guide us along the way to reading this map. So guys, I hope this helps. Again, this is just an introduction. I believe for your homework and quiz and test, you will be required to find points, label them. So if you have any troubles, please ask. Otherwise, know that I love you. Bye.